Hello, in today's class we shall be talking about Hooke's law. Now, the first thing we must state here is Hooke's law. What is Hooke's law? Hooke's law states that within the limit of proportionality, the extension of a material is proportional to the applied force. Let's put this in writing. It states that within the limit of proportionality, the extension of a material is proportional to the applied force. Now, this statement can be shown on a force extension graph, which goes in this form. Here is the graph. Here is your extension, and here is the force. Okay. Now, the graph is a straight line graph. All right. So here is the origin, point 0, and here is the elastic limit. So this is saying that as the applied force is increased, the extension is also increased. So I can write this in equation. It becomes extension is proportional to the applied force. Now I can take off this symbol. It becomes extension equal to K, which is the constant, times what? The applied force. All right, this is the Hooke's law. We can use this to solve more questions. Now, I want to derive another equation from Hooke's law as it relates to stress and strain. In this case, I will take off the force right here and the extension, and we replace it with the force with the stress, and also we replace the extension with the strain. Now, here we are seeing that as the stress is increased, the strain is increased. Okay, so this is a law that we can use to solve questions that involves Young modulus. So from this new graph, we can state another law which states that within the limit of proportionality of a material, the strain produced is directly proportional to the stress producing it. So I'm saying that from Hooke's law, we can state that within the limit of proportionality of a material, the strain produced is directly proportional to the stress producing it. That is another statement that we can use to solve for the strength of materials. So we can put this in equation forms. So it becomes the stress is proportional to the strain. All right, so we can replace this symbol with equal to sign. It becomes the stress is equal to a constant. In this time we use the capital E times the strain. So capital E here represents Young's modulus of elasticity. Is the Young modulus of elasticity. So we can make the E the subject. So now the Young modulus is equal to the stress over the strain. So with this equation, we can find the strength of a material as it relates to the material's Young modulus. And please note that all materials has a typical value for Young modulus of elasticity. So all materials like aluminium, brass, cast iron, they all have different values for Young modulus of elasticity.